Okay, so this is where we are finishing up with section 1 in chapter 5. And just as a reminder, if you have a negative exponent, you move it into the denominator. And so how I would do the problem is rewrite as 1 over z to the third times z to the eighth. And so what we're looking at is 1 over z to the 11th power, because we're multiplying, so you add your exponents. And I do recognize that there's other ways of doing this. For instance, another teacher might say, well, where is the exponent larger? It's larger on bottom. So then you can do the larger number, 3, and subtract off the other number, negative 8. So 3 plus 8 will give you 11. And because you get the larger one on bottom, it stays on bottom, z to the 11th power on bottom. Again, I recognize that there's other ways of doing this. So as I'm looking at letter B, that negative 5 to make it positive goes into the numerator, and then you add 3 plus 5, so your answer is just 7t to the 8th power. Again, I'm aware that some teachers might explain it differently. Which number is larger, 3 or negative 5? 3 is larger, so you subtract off negative 5, and it becomes 3 plus 5 will give you 8. And because it's larger on top, then the answer is going to stay in the top. You can do the same thing here, although this is how I would do it, like move the negative, so it becomes 3 to the fourth in the numerator, move the negative, so 3 to the negative second, it becomes 3 to the positive second in the denominator, and then subtract your exponents. And if you heard me in a previous video, I said that I'll accept it if you rewrite it as 3 squared, which is just 9. Please don't forget to reduce when you can. Let me just put a giant line there. So letter D, 5 over 15 would reduce to 1/3. So 3 in the denominator. I don't need to write a 1 in the numerator, because if you look at your B's and do 3 minus negative 4, you'll get B to the 7th. So you no longer need a placeholder. You don't need to write a 1 up there. So I wasn't planning on it. And don't forget about A either. So the larger in the denominator, so A is in the denominator, 2 minus negative 5 is 2 plus 5 is 7. There you go. Same thing with the next one. It might actually be to your benefit to rewrite it. Just move the exponents around, because you can't leave our answer with negative exponents. So this x to the 5th stayed in the denominator, but this x to the 5th moved to the denominator. So it might help some of you to show this work where you can add your exponents when you're multiplying, but then subtract for your final answer. So 2 over x to the 4th right there for that answer. So where I like these types of problems is when you can't just go to a calculator. You have to use the rules that we've established in class. So if you're multiplying with the same base, you add your exponents, and now there's nothing left to do. You just leave our answer like that. Notice that they have this statement where a and t are non-zero numbers, and x is not 0. Though you can sort of ignore those, because I'm never going to ask you to do a problem where you can't simplify it. But just so you know, I've seen problems on the SAT where they also give you a clue, like simplify x to the 3a times x to the 4th when, and then they give you this obscure statement, 3a plus 4 is equal to, I don't know, 12. Well, then the correct answer that they actually want you to do is write it out as x to the 12th power. I'd have to do some research to see, where this problem shows up, but I've seen it on the SAT. So if you're a junior, you might want to prepare yourself for questions like that. Same thing with this. If you understand that dividing with the same base, you subtract your exponents, the only thing I would encourage you to do is make sure that you put parentheses, because you need to distribute that minus to each term. So the correct answer is actually 3t minus 1t is 2t, and negative 2 becomes plus 3 because you have to distribute. So negative 2 plus 3 is 1. And this is the answer we're looking for here. Again, I strongly encourage you to understand all of this because I've seen on the SAT where they've had a phrase something like this, and then they have some obscure statement that doesn't seem like it makes any sense, like let 2t plus 1 equal, I don't know, 5, and then the correct answer is x to the 5th power because 2t plus 1 is equal to that. And a lot of students would like, how do you get from here to here? Well, it's understanding the rules of exponents. Sorry if that confuses you. You could have stopped at my boxed answer. And we're also throwing scientific notation at you. I believe you're probably familiar with this. All you're doing is you're moving decimals. So scientific notation, this first number, let me give you an idea, a times 10 to an n power. This a needs to be bigger than 1, or equal to 1, but smaller than 10. So that's where we get into this notation of you move the decimal until you get a number that's bigger than 1. So 7 is bigger than 1, but smaller than 10. So that's where we get 7.3. And then when you move for a very large number, you count how many times you move it. And I moved it 5 times. Okay, and you can go to a graphing calculator and type this in, and you'll see you'll get the same value. And then this is the same thing. You move your decimal until you get a number bigger than 1. So that's 1.04 times 10, and we count the number of times we moved it. 1, 2, 3, 4, 5, 6. And when it's a very small number, it's not a negative number. It's just a very, very tiny decimal. We use a negative exponent. And then we can do the same thing the other way. Is imagine for a second you move and I've actually seen students put it down 7.7, then count the number of times they move it. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be our answer. Don't worry about putting in commas. If you wanted to, you'd have a comma there, comma there. So it's 770 million. And then this one's the same thing, except with a negative, we go the other way. 1, 2, 3. That's where your new decimal is. 0.001025. I've also seen students put a 0 in front. You don't have to. And you should be ready for your homework right there.